Hello and welcome after the lunch break. Let's have a quick show of hands. Who would like this talk to be held in English? Okay, that settles it. Så jeg kan også snakke norsk, men jeg tror at dere ikke er nordmenn her. Er du? Okay, good. Okay, yeah, that's fine for me. I try to move a little bit. Okay, good. Can I have a picture? Okay, let's put that in. Yeah, that looks kind of okay. Yeah, okay. So, if that's not your talk, that's your cue to leave. I'm going to talk about prototyping IoT products and how to do that with the JavaScript. You don't have to photograph all the slides. I know they're awesome, but I just shared it on my Twitter, which is Coder by Heart, and there you'll find a link to the slides right away. A little bit about me. I've been working most of my career as a software engineer and doing, in the end, web-based applications. But I've never had to do stuff with hardware. And last year, I joined a company in Norway called Nordic Semiconductor. Who here has heard of that company before? Wow, 3 people. And you know me, so they like 2 people. We are the ones that put the chip in your wireless mouse and keyboards, if you have one from Logitech. Yeah, so like a hidden champion. And it's literally hidden. And at Nordic, there's a new stuff happening now in our industry that's called IoT. So there's a second wave of IoT, and I'm going to talk a little bit about that in the talk. But that's what I've been charged with. And that obviously means I have to deal with things that look like this. And well, that's the first year for me, so I'm going to share my experience. Fun fact, yesterday I found out due to some statistics somebody made, I'm the top 3 coder on GitHub in Norway. So there you go. Move to Norway, and then I don't know. Norway is really small, but that small? I don't know. Okay, disclaimer, obviously. Hey, I love JavaScript. I've been coding PHP for 15 years of my career, but that's over. And this is my personal opinion. This is not the opinion my employer has regarding languages, whatever. So please keep that in mind. And I will be defending JavaScript as the best backend language tomorrow, also in the panel where we talk about what's the best backend language. So please also come tomorrow. I think it's going to be fun. Nevertheless, here's your chance to win one of the things, and they are literally called thingy, that we built to make it easier for developers to get into BLE and Bluetooth and connecting stuff to the internet. If you tweet a picture of the talk to @NordicTweets and @CoderByHeart, that's me, I will raffle out afterwards the thingies and will distribute it to 2 winners, which are randomly selected tomorrow morning by breakfast. So let's get started. So what made me go into IoT? So why is that an interesting topic? We have a big screen, and it's really amazing. It's gonna be so huge. And the reason why it's gonna be big and why this is one of the many statistics you will find regarding the market of IoT in general and how it might grow in the future. I have the link to the actual study. To the study also in the slides. So this is not made up, and it's maybe one of the more defensive estimates. So it's going to be big and bigger and bigger, and one could think and ask, okay, why is that happening now? Like 20, 25, maybe even 30 years after we have machines connected to the internet. We have had IoT since the 80s. You have connected ticket vending machines. You have like factory floors that are connected. So what is changing now? Let's look a little bit into that. These are the 4 big industries, roughly, that will yield the biggest growth over the next 10 years, maybe. Nobody can actually look that far in the future, but since these markets exist and they are so huge, it's a pretty safe bet that stuff is going to happen there. First one is industrial IoT. As I said before, we have connected machines for a while, but what is happening and changing now is twofold. For the one thing is that we get the hardware is getting cheaper and cheaper and cheaper. The hardware is also becoming smaller and smaller and smaller. The chip size gets smaller. All the components get very small, which mean they also don't require as much energy as before. So I can now build an entirely new category of internet-connected devices, which wasn't possible before, which opens up a whole new field of application. I can build now very small sensors, which don't require a wired power connection. I can build a sensor that runs on 3 AAA batteries for 10 years. That wasn't possible before. And we are also seeing a new generation of, in the end, our customers, or your customers, people in managers, people who are, who are asking for more data. They are used to have real-time data about sports event, about the stock market, about they want to have notifications everywhere. They have grown up with this ubiquitous access to roughly personal data, in a sense, and they expect that from their business today as well. So there's a new consumer for IoT solutions, and industrial IoT solutions mean, in the end, there is something measuring data, and it's going to end up in some big data store, and then somebody's going to run machine learning on top of it and to understand when will this machine break down the next time, how can I optimize my costs, that's what it's about. And this is possible now, and there's a big demand happening. Second one, smart cities. Our cities were, and the infrastructure in our cities is 50 years old. And the concepts that were in place when they started to build these cities for cars is no longer sustainable. And it affects the health of people, it affects the health of our planet. And governments all around the world have understood that they can no longer build more roads to get more people in and out of the city, because more and more people want to move into the city. But actually, you have to make it attractive for people to not use their car. So that means you have to offer connected means of transportation from A to B, because that's where our cars are still superior. We go to the car, go in there, drive from A to B, and then we leave the car. No hassle. It's super easy, and that's why it's so convenient. And if we want to make people change that, don't use their car, we have to connect so many things, and that's where smart cities are going important. One example, in Norway, there's a law. The cities cannot have more cars coming into the city. There's a zero growth law. But cities like Bergen, which have roughly 250,000 people now, they will be adding 40,000 people in the next 10 years, I think. They have projects building that many flats. So there are more people in there. That means they have to actively reduce the number of cars that going in the city. And this can only happen, you can only go so far by forbidding cars to go in the city, because that won't work. So you have to be more attractive. Connected health, I think that's rather obvious. If we can measure stuff on a machine, we can also measure stuff on a human. And if you have, oh, I'm talking too much for that one slide. And it's not only about the patient, but also every machine, every thing you interact with while you're at the hospital. That is super, super expensive. And if the industry can optimize the time and the usage of these machines, there are billions of dollars that can be saved. By just having more data, knowing more about when will this like the heart rate monitor break down, when do I need to replace it? And that might be surprising, but only at like number 4 will we see consumer products, like your Fitbit, your smartwatch. It's a big market, but the real money is in industry, in real estate, in medicine, in transportation. Yeah, connected cars, that's obviously, some of these are a mixture between commercial and non-commercial or consumer versus business applications. So there was one thing, a new demand, possibilities open up, and one reason for these new possibilities that's happening now, there is a new mobile broadband standard, because your ticket vending machine from HVV or from RMV in Frankfurt, they operate on 2G networks. This basically, they are sending old school SMSs through the wire. And this takes a lot of energy, and it has low bandwidth, and it's expensive in so many ways. So what the telcos and the industry and everybody has been working on for a while now is now now being enabled in the first broadband networks, mobile broadband networks all over the world. Last week, Telenor in Norge, which operates the most modern mobile phone network in the world, they have enabled and launched narrowband IoT. So that's why it's really new. These are standards. These are standards which weren't available since this year. And standards like this, they reduce the costs for transmitting data. They reduce the costs for, in the end, your device. The amount of energy it's needed to transmit a byte is greatly reduced, and also the price for the data to transmit is reduced, because these new standards have completely different licensing models than before. So what is the big difference? Because we have actually, one would think we have network connectivity everywhere. We have Wi-Fi. We have even Wi-Fi here and in a cinema which is enclosed. So in rooms, why is that a problem? So you don't have to read that. That's page 1, and that's page 2. So these are the steps required to connect an IoT device. This is also an IoT device to the internet. That's the Amazon Dash button, which sends on a very high level. If you push that button, it will send the signal to Amazon, and it will order you toilet paper. So that's the high-level application. But under the bottom, what's in that device is actually there is a Wi-Fi connectivity chip that connects to your home Wi-Fi. And then there's a Bluetooth chip in there, which you use with your phone, which is, by the way, a $300 to $1,200 device, which you need in order to provision that button. Provision means to set it up so it works with the Wi-Fi. And this process also involves that you download an app. And there are, like, you can imagine, you are developers. There are so many things that can go wrong there. And the typical thing that goes wrong is somebody changes the Wi-Fi password. So that button will stop working at some point in time, and nobody at the customer side, at Amazon, is able to fix that. And there's a big reason why there are companies who today are not building Wi-Fi connected IoT solutions, because they have figured out that the actual customer support, so people will call the hotline and say, hey, my button doesn't work, my smart toothbrush doesn't work, my fridge is not working. The costs for that are so insanely high that they cannot make a profitable product. So the revolution that's now happening, and it is enabled by LTE-m and narrowband IoT, is that you can send this button to your customer. They take it out of the box, take out a small strip that disconnects the battery. It turns on, and it connects to the internet. There's no more operation necessary for the customer. And the fancy thing is, the customer can take the button with them. It's not constrained to the Wi-Fi it's connected with. It works everywhere. That's the beauty of using LTE-m. So the small difference between those is that LTE-m operates on existing 5G mobile broadband, so the thing that your phone uses. This is a license band. That means you have to pay and negotiate with your local network operator and the global operators. That's the disadvantage. The advantage is you can use existing infrastructure. That's already there. Narrowband IoT is a standard that operates roughly with the same physical properties, but you have to build your own network. You have to set up your own antennas. But this is an unlicensed band. That means everybody can build that, and that is usually used in cities, where a whole city is building a narrowband IoT network because they have, well, the places to set up antennas in lightings at buildings, and the things they have, like traffic lights, whatever, they don't move. Narrowband IoT does not support roaming. So you have your thing, it's connected, and it should stay at the same point. You can implement roaming, but that's not part of, that's not usually what it's used for. And as I said before, greatly reduced costs for the hardware makes it now possible to build really small things. So is that all to understand for IoT? Well, it gets even more exciting. So, because now if you think about LTE connectivity, so I traveled here from Frankfurt by train to Hamburg, and it was like no connectivity most of the time, because, well, mobile network operators, they want to build their antennas where their customers are most of the time, so in big cities, but not in the nowhere between Hanover and Hamburg. So, and that gets especially interesting if you build your IoT solutions somewhere where there's no land, or where the next city might be 100 kilometers away. So if you think about an offshore wind farm, there is no 5G coverage in the open ocean. So, or if you build it, in a forest, I don't know, somewhere in here around where the next city is far away. So, like, these are all connected devices, they all need internet connectivity. So they want to, for instance, transmit their usage data. They might also, you want to send them signals and say, hey, we know there's bad weather coming, so our predictions say you should like stop the rotation in order to protect the device. But it might not be possible to reach a very far outlying, very far away thing that's there, because it has no direct connectivity to a base station. So what's being done is we are building mesh networks so that one of these nodes might have connection to a base station, or there might be one of these nodes that has actually a satellite connection. You put a satellite dish on that one, and then you build an ad hoc network between these things and can send data back and forth. So you can, even that one can communicate, but by hopping through the network until it reaches an endpoint that is connected to the internet. These are things that are also part of what we now, since we're now moving stuff out of the factory floor where we have cables and we have power all the time and reception all the time, we are moving into a world where we are not connected most of the time, and that's also stuff we as developer, if we want to build solutions in that area, have to learn and experiment with, and that's what it's about. So it's very exciting, but it's such a huge, so much stuff that you need to learn. And what better way is there to actually do it? Like it's like when I learn, I don't know, writing a new library. I look at like first half page of the handbook, and then that's it. And let's get doing and like see how it feels and how I can apply it to my job and which problems I find. And today also we can no longer focus or just focus on one problem. Oh, cool, let's build a chip that connects to LTE, and then I sell that chip. And that does not work. Our customers, they are coming to us and say, hey, I want a complete solution. And if we as developers want to have an advantage over other developers worldwide who might be cheaper and can crunch out simple hardware and software, we will really create awesome products if we think about the whole chain. So we need to understand not only what the problem of our customers are, but what hardware are they using, which scenario are there, and so in order that we can give them the answer for the whole chain. And that's that can only work if we start not only. So I cannot write a good cloud solution. That's my main job. So I cannot just set up, hey, here you go, here's a REST API. REST works. I have worked in the past with REST. That's super awesome for like connecting, like for things on the internet, talking to each other. So that should work for IoT as well. If that's my mindset, then the solution we build in the end will not work in the real world. So I have to look and actually write software down to this hardware to understand how it behaves and what it's capable of. Yeah, and then now we come to the JavaScript part. So I have to, like, I understand that that's a different thing than a browser. Now, like, before I wrote backends for an application running in a browser. So I understand that that's a different kind of client, but I don't want to like code in C. So I looked into, okay, like the language I love and that works very well in many scenarios is JavaScript. So let's because if you So for those of you who were not able to follow the subtitles, that was Sebastian explaining the huge advantages of using a very, very awesome programming language called C, where you will write lean programs that don't use a lot of memory and are super fast. Yes, I would agree, and then we come to the point where this thing like explodes in your face, and you don't know why. So for prototyping, it's also about being fast and having a good experience and iterating fast. And if you have to debug compiler errors and seg faults for whatever reason, then it doesn't make it's not enjoyable. And if we think also in cross-functional teams where we actually want everybody in the team to be able to understand, okay, what software are we developing, what is it doing, why is it behaving this way, and what are we trying to achieve, JavaScript is a very high-level language where a lot of people can be enabled to write JavaScript code. If you try to do that with C, you will see more sad faces. So in terms of a healthy, iterative, innovative team culture and company culture, I think it's a good thing to start working with a high-level language, because we're building a prototype. We're not building a real device that goes out in the field in numbers of hundreds of thousands. In production, you will use C, that should be clear, or you will use something that compiles and is a compiled language where you don't have dynamic memory allocation. You don't want that in production. But for a prototype, it's perfectly fine if that thing crashes. Until you're building I don't know, weapons, stuff like that. So don't use it for that anyway. What I really like about JavaScript is, why am I seeing this thing down here? Okay, it's gone. So what's really awesome about JavaScript is, so who is JavaScript coder here? Yeah, okay, many people. So okay, I think we can skip that. Yeah. So JavaScript is awesome. Well, we talk about the advantages tomorrow as well. So let's go a little bit into the. I see that we are. Okay. Time is short, but let's nevertheless. The thing with JavaScript, it runs anywhere, and now it literally runs anywhere. So if you think about a connected device like a Bluetooth headset, you have where the app connects to the internet. You have Spotify as an example, for instance, and you might have on the bottom right there might be something where you have an IoT solution that runs on a factory floor. That's on the bottom right, a BLE sensor that's here. The sensor is connected to a gateway, which is connected to the internet. And if we look at these computing environments, we obviously have JavaScript on your mobile phone. You run it either in the browser or you write your JavaScript-based native applications. We run JavaScript on the server, Node.js. We run JavaScript in the cloud. I run my lambdas and write them using JavaScript. And we have gateway implementations, can also be done using JavaScript on a Raspberry Pi. So that's not an issue. And now we have these awesome devices that I brought that enable you to run JavaScript on a thing that is this small. So I know you can't see it because it's so small, but that example I brought here is an ESP8266 processor, which costs around $1, and it can run a JavaScript interpreter. That means there's a process running on that processor, and you are executing JavaScript on a virtual machine there. It's not compiling JavaScript to some C, but it's actually a real-time programming environment. And there's not one project, but there are actually quite a big number of projects that support executing JavaScript on these small CPUs. And to give you an understanding about the capabilities or the resources we have, look at like these numbers. That's roughly the range we have and that we get in a real-world IoT device in terms of how many megahertz do I have. So it's in that range, like low hundreds, maybe. And in terms of RAM, we're looking between 128 kilobytes or half a megabyte of RAM at max. So the point here in actually using a JavaScript, a physical device, is that I need to understand, okay, what are the resource constraints that I have there, and that I need to relearn a lot of the stuff that I forgot in the past. We moved so many computation power to the client, to the browser. We can execute so much awesome stuff in there. We can have VR there, augmented reality. That's all running in a powerful computer. The new iPhone has a single core performance that is faster than the MacBook Pro. So it's actually a supercomputer that you have in your pocket. But with IoT solutions, you have to think about reducing the. You don't have that much computational power. You need to conserve energy. You're not always connected. And that's from my experience. If you start connecting hardware, everything will take 10 times as long because it's so hard to debug stuff. It fails for interesting reasons. There is no better replacement. There's no simulation instead of using the real physical device. And then you can interact. Also, the point of IoT is not only get to run code on there, but to actually interface with physical devices. So you can actually prototype stuff. Prototype a smart lock and understand, okay, my customer might be a hotel chain. They would have a different requirement for a smart lock compared to a homeowner. And learning this stuff and building it that you can actually attach it to a real door, this will be something that will give you an advantage and an understanding of what to build. This is a long list. You can just check it out online. The links are in the slides. What I brought here and is the Espruino Wi-Fi. That's a chip that is powerful enough that you can actually make a secure connection to a cloud. So this chip, and as it runs now, and what it displays is it's connected to AWS MQTT using a TLS encrypted connection. That means we have an end-to-end encrypted connection. And if you're building IoT solutions in the future, we also have to think about making it safe. Because many things that today connect to your Wi-Fi are very, very insecure and susceptible to being hacked. Because you can just man-in-the-middle attack the router, the Wi-Fi, and then you have access to the device. As in a commercial solution, you don't want that. You want to be sure that your device only connects to an endpoint it knows, it is trusted, and on the other hand, you will also want to make sure that you are only sending data to a device that you know. And only an end-to-end encryption will enable that. So the Espruino Wi-Fi is compatible to Arduino. That means you can connect all the Arduino shields you know by using a breadboard. The great thing is the form factor. So they didn't use the Arduino form factor, which if you have a board that uses that, so Nordic uses them, they are really big. So building like a simulated smartwatch with that will be really clunky. But you can imagine that using only this size, you can actually build something with a battery, and you can wrap it around your arm, and it simulates pretty closely how a real device would look like. It's 35 euros, so it's pretty cheap. And you get an integrated browser-based IDE, where you can write the code you love. So you get a JavaScript process where you have your async code, you can work with timers, you can work with callbacks, and you don't have to deal with memory allocation. It takes care of that for you. So you can focus on actually on creating, on building the business logic. Okay, there's a big section on MQTT in the slides as well. As I said before, REST is not the way you want to talk to your devices. Look into MQTT. It offers a lot of advantages for internet-connected devices. And it's a simple protocol. It's well-defined, not a lot of pages, and it's widely used. And it has become the internet standard, or sorry, the standard with basically all cloud providers support MQTT. It's actually also quite cheap. So if you're thinking about costs in IoT devices, that's usually not an issue. So your devices have not that much power, so they are not sending a lot of data. So prototyping in IoT doesn't cost you a lot. So you can, the free tier will bring you very fast on AWS. Also in Azure, and Google Cloud also supports MQTT. So for the demo, unfortunately, I'm out of time. I have a demo. What the demo this device is doing is connecting to a broker. The source code is also linked in the slides. It connects to AWS, fetches its state. So I think I also got disconnected from the Wi-Fi here. Fetches the state, and you can send icons to it. So the source code in the demo also shows you two-way communication between the device, gives you a little bit of understanding what you want to do if you want to send messages to a device, and that's in there. Yeah. So there are more examples in that repository. I also built, when we talked about smart lock, about an NFC reader that you can connect. So the NFC reader is also a standard Arduino shield, which you can use to simulate a smart lock. And then it would be time for questions now. And no questions. Yes, Christian. So the question was, does the input language, so the language I write my program in, turn on the LED, which I showed in the example, differ from what's actually executed on the device? No, with these devices, the process that's running on the device right now is a JavaScript interpreter, and you get a shell where you can connect directly to the device and execute JavaScript on there, on the fly. So you can inspect what's in memory, you can turn on and off stuff, so you don't have to compile it. And that's really one of the big advantages of the Espruino project, that you get this REPL feeling. Yeah. So I have my editor, and let's see if I can show it. So here, just as an example, that should go away. Yeah, please don't forget to rate the talk. That would be really awesome. In the app, if you can also always send me feedback. So this is how the Espruino editor looks like, and you have on the right-hand side you have an editor, and you can upload code, and this is the whole program for getting this to run. Connect to an MQTT broker, fetch data from a state, apply it to the displays. It's 200 lines. And so the Espruino project offers you so many pre-written modules for connecting hardware, like an NFC reader or these matrix displays. You don't have to write them up. They are there for you to use. And then on the device, I can, here I have a real shell. You might be able to see it, where I have things like console log and can output variables, whatever. Yeah. Okay, there's another question. Good question. How do you build a deployment pipeline for this? I don't. It's like this is a purely prototype project, where you will actually know each device by name. So it's not like you won't deploy a fleet of thousands of sensors using Espruino. That's not the point. The point is that you get to know also your peripherals. So basically the stuff that you're connecting to the CPU. So this board offers you a CPU and pins. These pins you can connect to other hardware, either digital or analog. So you can find a temperature sensor that works for you, or a lighting sensor, or infrared sensor. And NFC is another kind of sensor. And you figure out for your problem, or for the problem of your customer, how could a solution look like? What is their problem? Do they want to count how many people walk through the door, or do they have a safe that should be locked for certain hours, or whatever? And that's the point of the prototyping. Understanding a business problem and figuring out all the components I need. I need hardware, I need a cloud application, I need a management interface, maybe I need a mobile app. And that's the idea there. And once you have figured out your building blocks, then you go towards the next step, and this is actually building a device where you take your sensors you have picked and your CPU and put it on a PCB, and then you build like 100 things of these, and this is the next step, and you can order this then online. But that's then the custom build is the next step. And then you think, and even at that step, there is no deployment. Deployment pipeline really makes sense if we're talking about thousands of devices. Does that answer your question somehow? Okay. Yeah. Prototype. Fast iteration. So that's the thing. Okay. We have 1 minute. Last question. Yeah. I also have an anonymous feedback form in there, so if you want to give feedback anonymously, I'm very happy to take that as well. Okay. Then I will be here now and later and tomorrow as well, so I'm happy to talk to you. Thank you for listening, and enjoy the rest of the conference.